welcome back to the tutorial. In this particular video, I'm going to be showing us how you build the phylogeny tree, okay, from the files we've prepared, saved as what? Mega file. This is still my Mega 11 tool or software. I'll simply go to what? My phylogeny. Around this particular area, you see different, options you can work with, with respect to this particular software. We have already performed alignment, so we simply want to build our phylogenic tree or evolutionary relationship, between the files we have. So I'll simply go on the phylogeny and click on phylogeny. It will ask me, do I want to construct this phylogeny based on text maximum likelihood tree, or text neighboring joining tree, or text minimum evolutionary tree, and the rest. These are different ways you can build your tree, but they all use the same, algorithm to perform your task. So at the end, they will generate all similar result or same result. So for the sake of this tutorial, I'll be using the text neighborhood joining tree. So I'll simply click on that. Okay, this is what I have. This is my desktop, and this is my sequence in mega file. We've saved that in our previous video. So if you haven't watched that, you can refer back to the video and get that from there. So I'll simply click on this, which is the file I'm looking for, and I'll open it. Once I open it, it will load and it will ask me this, okay, because I'm doing this for the first time. It will ask me this, scope, this, where our major interest is here is in the text of phylogeny. You don't need to leave it in none. There is no option here, but once you tap on it, something will come up, okay? So you simply tap on this arrow. We can use bootstrap or interior branch test, but for the sake of this tutorial, we'll use the bootstrap method, okay? It will tell you that the number of bootstrap replication could be up to 500. This is editable, okay? But for the sake of this, we can use it, leave it at default. And other information, you can still leave it as default. So the number of thread and the rest, this is okay. So I'll simply do hit on my okay. And it has started reading and trying to build my tree, okay? Once it's done reading this, you will see the phylogenic tree output result. Okay, it's done reading that. Okay, I just maximized that. This is what I have. Okay, towards this top, you see the original tree. You see the bootstrap consensus tree, which is the one we are going to be making use of because it explains this better than the rest. So I'll simply click on this, and this is what I have. Okay, this is the tree. As you can see, this is my target sequence. Okay, this is my target sequence, and these are the rest of the organisms. I am trying to see how related they are to my organism via evolution. Okay, this is my target sequence. You can see the bootstrap numbers here. Okay, this number here is trying to tell you the level of similarity, among these particular organism. For instance, this is my this target now. If I trace this target to this particular point where it joins with this next row, you discover that this particular branch here is about 90% or 90% similar to my target sequence. Whereas this same 90 here, this one with this is 56% and 57 and the rest, okay? So this number is just trying to, relate to you how similar these sequences are, aside the tree here. From the tree, you also notice that these particular sequences here are the most related to this particular target sequence. That's why from the sequence you see it joining with this. So this joining just tries to also establish to you the different similarity, or the way these organisms are related. For instance, these two organisms here are very, very related, up to 98% similarity. So you see the two of them out, single themselves out and come together here. The same thing happens here. These two are very similar, and the rest, This now you see that's how all applies. Okay, so this is simply trying to build, go over the different organisms you have there and build what a similarity or relationship, evolutionary relationship, using the faster sequence or the genetic makeup of your organism with the ones you are trying to work with. So this is our phylogenetic tree. In our next video, we'll be showing how we can, you know edit one or two things here, maybe to label it properly, or and also export it, to our working MS file or presentation file and the rest. See you in the next video.